The feedstocks used for the manufacture of cement are the natural raw materials limestone and clay. These are broken down in crushers into fragments of about 1 kilogram and then ground in a raw mill, together with smaller amounts of iron ore and quartz sand to obtain a fine meal. At the same time, they are dried with the hot kiln exhaust gases from the incineration process. This raw mix is then transferred to a rotary kiln and fired at temperatures of about 1450 degrees Celsius to produce round-like particles measuring about 3 centimeters, known as cement clinker. Sintering is the name used by experts to describe this important process, which needs an enormous amount of energy. In this incineration process, chemical compounds are formed which later cause the cement to harden when mixed with water. After the incineration process, the cement clinker drops out of the kiln and is cooled to about 200 degrees Celsius in a grate cooler. After adding gypsum or anhydrite and sometimes further ground additives like slag, fly ash and limestone, the clinker is ground in mills to produce fine cement. The quantity and type of the additives influence the chemical and physical properties of the cement. The cement is stored in silos and is mostly supplied to concrete manufacturers as bulk material for further processing. Concrete consists mainly of a mixture of cement, water and aggregates such as sand, gravel and crushed rocks. At the concrete manufacturing plant, the cement powder from the storage silo is transferred to the mixer. All the concrete components are weighed exactly before being added to the concrete mixer for a specified time. Finally, the chemical admixtures like the superplasticizer glenium is added. In this process, the cement-water admixture slurry becomes the glue, also known as cement paste, that holds the aggregates together. The fresh concrete mass then flows into mixer vehicles to be transported to the construction site. The properties of concrete can be specifically varied by using different mixture proportions and admixtures. The admixture glenium, for example, increases the flowability of the concrete so that the densely packed steel reinforcement bars of a foundation can be coated quickly and completely with concrete within a short time. A pilot plant comparative study between conventional concrete and concrete with added glenium, but with the same water content and mixing ratio, clearly shows. With conventional concrete, the flow process already stops after 5 seconds and after a distance of about 25 centimeters. Concrete to which the superplasticizer glenium was added flows much faster, and the distance traveled over the same period is about 65 centimeters. Modern superplasticizers like glenium are based on synthetic organic polymers such as polycarboxylate ether, called PCE for short. A PCE molecule consists of one long main chain and shorter side chains. The main chains are negatively charged. When cement is mixed with water, it reacts and starts to form crystalline needles that interlock with each other to form a hard, rock-like substance. When the PCE molecules are mixed with liquid concrete, they are absorbed onto the surfaces of the particles contained in the concrete. The side chains of the molecules point outwards, like the spines of a chestnut burr, and hold the particles at a distance to each other. This makes it easier for them to move against each other, and the concrete becomes more fluid. Concrete can be given the desired properties by varying the length of the main and side chains. BASF, the chemical company.